Good morning, students. Today I am going to discuss about RC coupled amplifier. That means resistance capacitance coupling in short-term RC coupling. This is most widely used coupling technique in amplifiers. So the details of this two-stage RC coupled transistor amplifier circuit are follows. The two-stage amplifier circuit has two transistors. One is Q1 and another one is Q2, right? And this is connected in CE configuration. CE configuration means common emitter configuration, where the emitter is the common emitter configuration means where emitter is common between input and here if you can observe this one, this is common emitter. Here if you see this is a common emitter, that means this is input and this is output. And the common power VCC is used. The potential dividers R1, R2 and the RE form the biasing and stabilization network. That means R1, R2 puts the always this, what you can say, small fixed current to the base. The emitter bypass circuit CE offers a low reactance path to the signal. So that's why it is very much important. And the resistance RE is the load impedance, and the capacitor CI or Cin, this is one C is the initial stage of the amplifier couples AC signal to the base of the transistor. So from this, the input signal is given to the base. As you know, the capacitor blocks the DC. That is why you are using the capacitor here. It supplies only AC signal. The CC is the coupling capacitor that connects two stages and prevents this interface between the stages and controls the shift of operating point. So whatever, if you see why it is called as RC coupled amplifier, it is a combination of R and C, So that is why it is called as RC coupled amplifier, right? Here in this case, when AC input signal is applied to the base of the transistor transistor 1, it gets amplified and appears at the collector load RL, or that means RE, which is passed through the coupling capacitor CC to the next stage. This becomes the input of the next stage, whose amplified output again across the collector. This is where the capacitor collector load, thus the signal is amplified stage by stage action. The important point here to be noted here is the total gain is less than the product of the gains of individual stages. So this is because a second stage is made to follow the first stage. The effective load resistance of the first stage is reduced due to shunt affecting of the input resistance of the second stage. Hence, in a multiple stage amplifier, only the gain of the last stage remains unchanged. Here we have considered two-stage amplifier here. The output phase is same as the input, because if you see when the input signal is applied at the output of the first stage, it is a 180 degrees phase shift, you can observe here. And then after the second stage, it is a 360 phase difference. Okay. So this is about what RC coupled amplifier. Only points to remember here is this capacitor C1. This blocks the DC and allows only AC, and coupling capacitor, which which acts as an input to the second transistor. Through this, it has been sent to the second transistor, and C is a shunt capacitor to protect the CE configuration to put always this in the forward bias. And this is about the operation of RC coupled amplifier. Now let's see the frequency response. From this graph, it is understood that the frequency rolls of or decreases for the frequencies below 50. If you see, there is a rollback at below 50 hertz and at the frequencies above 20 kilohertz. Okay, where the voltage gain for the range frequencies between 50 and 20 hertz is very constant. So already we know the capacitance Xc is equal to 1 by 2 pi Fc. Here the capacitor reactance is inversely proportional to the frequency. At low frequencies, that why at low frequencies less than 50 hertz, you can observe the capacitor reactance is inversely proportional to the frequency. At low frequencies, the reactance is quite high. That's why the reactance of the input capacitor Cin and the coupling capacitor Cc are high and only a small part of the input signal is allowed. That's why you can observe this rollback at less than 50 Hz, right? So this is at low frequencies. Coming to high frequencies, small part of the input signal is allowed. The reactance of the emitter bypass capacitor Ce is also very high during the low frequencies, hence it cannot shunt the emitter resistance effectively. So at high frequencies and at low frequencies, at high frequencies particularly, we know that the capacitor reactance is low at high frequencies, so a capacitor behaves as a short circuit at high frequency. As a result of this, loading effect at the next stage increases, which reduces the voltage gain. Also, this as the capacitance of the emitter diode decreases, it increases the base current of the transistor, due to which the current gain reduces. Hence, the voltage gain rose. At low frequencies, because of a high reactance, there will be a rollback. At high frequencies, because it acts as, the capacitor acts as short circuit, because of that one, the base current increases sharply. So the Q point or whatever operating point shift from active region towards cutoff region or saturation region. That's why here at high frequencies there is a rollback. So this is about the RC coupled amplifier. Thank you.